A brief introduction first. My name is Matthew McKnight. I'm a technical specialist at Autodesk. I support the manufacturing range of technology and solutions that we have here at Autodesk in Australia and New Zealand. I'm based out of Melbourne, and today we're going to be going across the factory design from 1D to 4D. So really what we're talking about here is from concept through to commissioning as the summary of this presentation. Actually, if you were to break it down and give you a little bit more information, really we're going to cover the complete workflow. And this is going to be looking at the technology that we have available to cover working from process planning, where you're working in a very conceptual stage. You're not necessarily worried about CAD, whether that be 2D or 3D. But then how do we move from that through to doing, conceptual layout to detailed design? How can we incorporate value in that process through the use of scan data via reality capture? How can we equate that to time by incorporating the 4D aspect of that with a timeline? And how can we create or capture a virtual factory experience as well for users to experience as a part of this process? Now, typically this process would be done and has been done for quite some time just using a number of quite simple methods. It's very common for us to see customers using AutoCAD as the basis of their factory layout system, and in some cases the only way that they actually define and optimize their layouts and designs. Sometimes you might find that this is done in Excel, and sometimes they may complement one another, AutoCAD and Excel. The reality is, though, there are a lot of pressures on manufacturers, on factory designers to optimize their system much more than ever before, because it can be quite costly to realize at the end of the process that the system isn't optimized and you have to go and make change. So what we're going to be doing today is we'll run through a real-life example of how you can apply the technology, in this case to a data set from one of our customers. Like I said before, it's not uncommon for customers to be using, say, Excel or 2D drawings to try and replicate this process, but the complexity of systems nowadays means this may not necessarily be the best solution. And really the layout process has evolved over recent years. Having a factory digital asset of your entire factory adds a lot of value when it comes to making informed decisions associated with planning, building and operating your factory. So today what we're going to do is we're going to look at the different authoring tools that you have at your disposal to improve this workflow. Hopefully this goes on to provide a positive impact on things like time to market and time to volume and even overall equipment efficiency. Furthermore, I hope it helps you sell new products sooner, increase your throughput and run in a more cost-efficient manner. So let's jump straight in by looking at the workflow. And like I said today, the idea is to show you a complete workflow from 1D right through to 4D, the initial concept through to commissioning of the factory layout. Starting off with 1D, and this is, like I said, it's typically done inside of, say, AutoCAD or Excel, where you're trying to approximate the processes or parts of the process and the impact that they're going to have on the overall project. Now, Autodesk, we have technology that can help you do this, and it's actually little known technology. There's not a lot of customers actually are aware of this technology, so I'm glad to be bringing it to making you aware of this. Now, the technology that we'll be referring to here is called process analysis, and this helps you model, study and optimize those factory processes and workflows that you anticipate using. You can quickly and easily analyze workflows and help you hopefully find those bottlenecks in the system and hopefully remove them prior to actually starting to commission the plant. This therefore reduces the risk of not finding those issues until potentially later on down that process. And the great thing is that all of this information can then be captured in detailed reports that can then be kept for archival purposes or shared with various stakeholders in the project. So let's have a quick look at what this process looks like. And again, like I said, the technology that we'll be using here is called process analysis. This technology can help you model, study and optimize those factory processes and workflows, and we can start this by actually importing existing data that might be coming from the shop floor in the form of an Excel file. We can also start by dragging new blocks from the factory asset library out into space. In this instance, we can lay out either the entire process or part of the process that we want to simulate to try and understand any potential issues we have before we actually start moving through to any form of design using 2D or 3D data. So you can see here we have materials that are coming in, they're going through certain processes, they're going through a weld cell, they're being unclamped, and then moving on to maybe the next stage of the process. At each stage we can add parameters and properties to those components of the process, and then once we've done defining those, we can simulate the process running over a period of time to, say, in this instance, understand the number of components that we can complete within this specific time frame. Now, if we realize that in this instance we can't produce the number of components that we need to, we can then modify the process. In this case, we're duplicating the welding cell by adding a second one through copy and paste, which is simple and easy, and then rerunning the analysis. Now, from this, we can understand, the performance of our system. But this can also be then detailed in a detailed report that captures a lot of this information, including when equipment is blocked or idle, or if there's downtime for a specific machine. And the great thing is that this report can be saved for historical purposes. It might be you might want to save it and share it with a customer or various stakeholders. Maybe you've got a machine supplier that you'd like to pass this information on to them. So a fantastic tool, again. It's one of the lesser known tools from the range of technology that's available to improve, but hopefully you find some value in using that in your workflow. So once we've done that process analysis and we've understand the best configuration of our system, we can then start to move into a conceptual layout design where we start to use 2D assets to define the locations and positions of equipment within inside of the workspace. The great thing about this is the information that we've defined and determined using the process analysis stage can actually be used to drive the 2D conceptual layout. So this reduces the duplication of doing the same as effectively what you've done in the previous step. It's also great for existing users of AutoCAD because you'll find that we're working directly with inside of AutoCAD, so it's a familiar environment for many of you, making it quick and easy to design and manipulate your data. Also, the assets that you will have previously used inside of process analysis are common across both environments. So the assets that you've previously used inside of process analysis to define the process are then transferred across and become a part of your 2D layout. And smart connectors, when working inside of this environment, make it quick and easy to be able to place and align components within inside of this space. So let's again have a look at that. So we've defined our process using process analysis, and we can export this as a DWG file, which we can then open inside of AutoCAD. And again, for those of you who are familiar with using this environment, you'll find that we're just using standard commands here to place and copy, rotate components, and then position them into the location that we expect. Here we can make sure that we're trying to avoid any existing structure that we know based on the assets that we already have available to us in this 2D form. But we can also place additional assets. So if we wanted to use the library, we can place components like cable trays, conveyors, guardrails, pipe, conduit, even safety fencing and more. And you'll notice that they also, in many instances, snap together. So you'll see here that when we place additional components to the conveyor here, they will actually snap to connectors on the existing components that are in our layout. So you can see here that the idea is to try and speed up the process by reusing the information that we've already defined using process analysis, but then also to leverage that information and more information that's available to us in the asset browser to define any additional components and infrastructure that we need. So once we've done the conceptual layout using AutoCAD, Now we can move this into a 3D environment and start to gather more insight as to the performance and any potential issues with the layout of our design. Again, the great thing here is that we can leverage all of the work that we've done so far as part of this connected workflow to convert the 2D layouts from AutoCAD into 3D with inside of Inventor, and that's done using a single click. The idea is to reduce, this interconnectivity between or associativity between the 2D and the 3D environments helps reduce the likelihood of errors when moving between those two environments. And again, like we saw with inside of AutoCAD and the 2D environment, it's easy drag and drop type of environment where we can grab components or assets from the library, place them onto the factory floor, align them and snap them together as we've seen previously. And highlighting again the fact that we're actually using this library of assets that we've used in the previous two stages of this process. So when we worked through our process analysis, then we worked through our conceptual layout, now we're working inside of the detailed design environment, we're referencing the same information across all three environments. So again, let's have a quick look at what this looks like. We'll see here that there's a one-click transfer from AutoCAD into Inventor, and the information is automatically populated because we're linking this information to the two environments, but also to the factory assets that we've been using common between all of those. You'll also notice that when we place components on the floor, they automatically snap, and we've got manipulators to be able to reposition or reorient those components if we'd like to move them into other or alternate positions as well. So again, the speed at which you can create this 3D asset, factory asset, is quite phenomenal based on all of the work that we've gone into so far in this process. Now it's about at this stage that people start to ask me a little bit about the factory assets. So I'd like to just pause for a moment and spend a little bit of time to show you how you can create factory assets and how they're stored within inside the library. The great thing is that the creation of the factory assets is fast and easy, and it can be done from Inventor models or most other 3D file formats. But once you've published these models, they become associative across the library, and they automatically create the 3D and the 2D asset for you. Landing surfaces and connectors can be quickly created to help you place and align the components within inside of that workspace. And one thing we haven't mentioned at the moment is not only is this information shared across your various different technologies that you're using at each stage of the process, but this can be shared then with other team members outside of that using a cloud-based system which is syncing data between different users within inside of a workplace. You'll also note that by standard, even without any custom content, that there's a whole range of standard content that comes available out of the box upon installation. So let's have a look at what this workflow looks like. So the idea here is to really show you how quick and easy it is to be able to create these assets no matter what CAD data you're working with. So here we have a storage rack that's created in Inventor. You'll note that we have an Asset Builder tab, and within inside of that tab we have the tools necessary to define the landing surface and also define connectors as well. We can define all of this information quite quickly and easily, which we're stepped through the process of doing. And this saves you the time of inserting constraints within inside of the assembly environment. If we publish this asset, we can place it into the specific location. And by doing so, it's actually attaching all that information that we've defined, the landing surface, the connectors, but it's also inserting the 2D representation. Now you'll see all of the various different file formats that we can import. In this instance, we're going to use a SolidWorks file as an example of a third-party file format that we can use, but essentially the rest is very similar. We can go through and place a landing surface, define our connectors, and then publish this asset, which is going to upload not only the 3D, but create the 2D asset that goes along with it. Assets, when we use them inside of our design environment for the factory layout, are through the library, and the library is defined in a reasonably logical order because you define it, and we just drag and drop those components in place. You'll notice that certain items have tags above them. In this case, the storage rack does. We can change these, and any interconnected components will change as a result of those. You'll see that the other one that wasn't connected doesn't change, but the moment that we drag it in place, it does change to reflect the properties of the others. This is great because, and one other thing that you'll notice is when we change these properties, the eye properties of the components actually update as well. So if we're using this information in bills of materials, it is associative to the changes that they're making. You'll notice here that when we use the SolidWorks robot and place it, it works in much the same way as our native Inventor files. So hopefully what you can see here that this whole process speeds up the creation of your assets, but not only the creation of your assets, but the placement of them as well. So let's move now on to the next stage, and this comes again here with inside of that detailed design, and this is really about the engineering review and analysis. Now, as we've tried to point out, we can create assets that are multi-CAD, as in they come from various different file formats, but it might be important for us to be able to work with design data that's coming from various different parts of the facility that we're working with. Take, for example, actually the structure, which may not necessarily be designed in a typical mechanical design system. Also, we might want to take into account the surrounding infrastructure. In this case, a point cloud data can be used, which is scan data and brought directly inside of that environment to either design based on or review for clash and interference. Now, we can communicate our design intents by doing walkthroughs and fly-throughs. And as I just highlighted a moment ago, we can also do clash detection and clearance analysis, not only with other CAD data or other surrounding components, but also with mesh data that replicates the location of existing facilities and infrastructure. 4D simulation, which is time dependent, enables us to look at the installation sequence of factory floor equipment. So if we could just use our CAD system, we would get the initial state where there's maybe nothing there. We'll get a final state where some of the components are there. But it's not really defined in the installation sequence and timing that will actually used through the commissioning of the project. So by doing this, we're actually showing the construction of components through that time sequence. And we also have collaboration tools that make it easier to be able to share this information, even for those people that aren't so familiar with the use of CAD software. So again, let's have a quick look at what this looks like. Now, design review can be done using a virtual walkthrough, and that's what we're doing here. We're actually walking through the facility to be able to understand what that looks like. This can help us capture potential problems much earlier in the design process, hopefully enabling the system to become more efficient and less costly for us to impart. You can capture a wide variety of different file formats. Even formats like Revit can be imported into Navisworks and as part of this design review. Here we can run things like clash detection. You'll notice in the top of the screen there, we actually have some cloud point data, scan data that's been brought into our review area where we can actually do a clash detection. Now in this case, it does highlight to us that the crane there actually interferes. Now because we have an associative link between the Navisworks, the design review area, and our assets, our 3D data, we can go back inside of Inventor, make some changes to those cranes, reduce the height of them, go back inside of Navisworks, and this updates. Now that we've done our design review and we're happy with the design, we move on to the next stage of our detailed design that's actually producing the drawings necessary for installation and commissioning. Now, using Inventor's advanced drawing capabilities is really quite quick and easy. So it's very quick and easy to place the design views, and we can update those, most often done in real time. But we can also place things like equipment bill of materials, which will actually show all of the components that are required by our system. And we can place a series of balloons to highlight each of those in our drawing views. And these are associative to the changes that take place to our model. So again, design review through to final production drawings very quickly and easily using this workflow. Now furthermore to this, reality capture is something that we highlighted in this previous stage. And I want to just spend a moment talking about this because it's one of the, an often overlooked part of the process, but it is often a part of the process that has some of the biggest value for users of this workflow because it has the potential to capture a lot of the issues that typically happen when upgrading systems within inside your factory layout. It has specific tools that help you work with scan data And these tools can be used across a wide range of data sources. So from a wide range of machines and scans or scanners are available. So you can bring in multiple scans from multiple different machines into the one environment. Now this can be directly imported into Inventor or Navisworks for that matter. You'd bring it into Inventor if you wanted to incorporate it as part of the design stage to try and avoid any potential issues, but you could incorporate it as part of an overall design review as part of that Navisworks review stage. And regions can also be hidden quickly or segregated and hidden quickly so you can hide unnecessary information. So let's have a quick look again at this workflow and what it looks like. So here we are inside of Recap, which is our solution for working with scan data. You'll notice here that we've brought together scan data. This scan data has come from a Faro laser scanner, but we can create regions within inside of the scan data. Maybe we just want to segregate down into areas, or maybe in this case we actually want to be able to hide a specific region, which is what we're doing with the top of the facility there. It makes it a little bit easier to be able to see in. Once we save this, it's saved in a recap format, and this recap format can then be brought directly within inside of Inventor and leveraged as part of that design workflow. You'll notice that on doing so, we can insert into a specific position, so we can locate that accurately, but we can also increase or decrease the mesh density based on our preferences inside of this environment. The navigator enables us to go back to the regions that we defined within inside of Recap and quickly and easily hide unnecessary information so that we can narrow down to just the specific information that we need to see. So again, really this is, offers a lot of potential for customers that are designing complex systems in existing infrastructure, and they want to make sure that they don't have potential clash issues with their designs prior to installing equipment. Now we move on to the last stage of the process that we'll be talking about today, and this is 4D. And 4D is really talking about the time dependency of that process. Here, we actually want to show the construction process in relation to time to help avoid any potential issues. Typically we either look at the state, at the start of a process and the end, but by looking at each point along the commissioning stage, we can actually help avoid any potential issues whilst we're inserting and assembling and commissioning the facility. This provides for flexible planning, so you can plan based on, using the interface with inside of Navisworks to define that timeline, or you can import your timeline from tools such as Microsoft Project or Excel. And from this you can do design review, but you can also export this information out to animations that can then be used with customers, suppliers and contractors for further review downstream. So again, let's have a quick look at what this process looks like. Again, we're going to begin in this instance by looking at the installation and commissioning stage of the process. And here we're going to be using planning tools. Now, like I said, these can come from direct input with inside of Navisworks, or we can import this information from the likes of Excel or Project. Here we can see the assembly process that we anticipate following as part of the commissioning stage of this project. And you'll see that we can associate each time to a specific asset within inside of the environment. And then as we move through the timeline, we can actually see the project come to life as we expect it to be built or commissioned in real life. From this, we can then create an animation which can be exported and then viewed on tablet or other mobile devices if necessary, and distributed to downstream consumers of that technology. And furthermore, virtual reality is another means by which we can review our factory designs as part of this workflow. Now, for those of you who caught my webinar prior to Christmas, hopefully you will have seen it's very quick and easy to be able to create a VR experience using 3ds Max Interactive, using assets that are coming from the likes of Inventor and Fusion. Here we can create not only this VR content quickly and easily, but we can animate it and create interaction with it so that it reacts and interacts in much the same way as the real world does. Hopefully this enables you to find potential issues that might otherwise not be able to be found if we were just looking at it through the screen. The other thing that is often being used for by our customers is to be able to sell an idea or a concept. Maybe it's to sell internally or potentially externally. Maybe you're looking at winning that next project by highlighting some of the good work that you've done on some of your previous work projects. Now, I'm not going to go into any details about how you go about creating this. We spent quite a considerable amount of time in our previous webinar. What I wanted to do was just again highlight the fact that you can create a very interactive experience. Here is a factory workflow that is being highlighted in virtual reality. You can see that we have animation and movement from robots inside of this space. We have processes that are taking place. And as a user of, or someone that's going through this experience, I can move around and interact with that. So much more, I get much greater insight potentially by using this as a design review tool or as a sales tool than I might by using some other methods that are available to us. So there you have it, 1D to 4D. Now, in brief summary, let's cover off some of the topics that we've talked about today, because I think it's important just to do a really quick review of what we've been able to show. So firstly, we've shown an integrated workflow for the factory layout. We've moved from our conceptual process analysis through to conceptual layout, to detailed design, to commissioning of our factory layout. Hopefully you've realized the importance of that process planning. I've tried to point out to you the fact that process analysis can really help you avoid any potential issues long before you've actually started to do the layout design in any form of CAD system. We've shown that you can quickly move from concept analysis to detailed design, and this is part of that connected workflow of using these solutions that all interoperate with one another. We've seen that you can quickly create factory assets, not only from Inventor models, but from other CAD models as well. We've shown more recently how you can work with reality capture as a part of that factory layout workflow. We've seen how factory communication can be enhanced with other stakeholders, and we're also seeing how virtual reality can enhance that process as well. Now, how do you get there? What's the path of actually moving to this type of process if maybe you're more familiar with a traditional process? Well, the great thing is, and this is reasonably common with a lot of the conversations that we've been having recently, is that the product design and manufacturing collection is most likely the best path for you to look at. We've highlighted in previous webinars a range of the technology that's available as part of the product design and manufacturing collection. It includes technology like Inventor Professional, like Vault, like AutoCAD. But looking back at what we've talked about today really does highlight the value to you of the product design and manufacturing collection. If I single out just those components that we've talked about today, we'll see each of these shown in these 7 items here. So if we go back to process analysis, this is part of the factory design utilities. If we then look at our conceptual layout, we used AutoCAD architecture. If we looked at our detailed layout and design, we used Inventor Professional. If we were looking at reality capture, we were talking about Recap Pro in that instance. If we were talking about a design review, we were then moving into Navisworks Manage. If we were talking about creating virtual reality experiences, here we were referring to 3ds Max and 3ds Max Interactive. And underlying all of these technologies is Vault, which is managing the data through the process. So again, in my eyes, the best path forward for customers looking to adopt this type of workflow is through the product design and manufacturing collection. Okay, so it's been a rather short presentation today, or webinar. I just want to, before we wrap up, say thank you. If you're after further information about the workflow that we've shown you today, our resellers across Australia and New Zealand are very familiar with the technology that we've shown. If you don't have a reseller, you can find your local reseller by going to autodesk.com/resellers. You can also find further information about the product design and manufacturing collection by following the link that's shown on the screen there as well. If you do have questions, specific questions, and if you haven't already asked them, I haven't looked at the question panel yet, but I will when I jump off this webinar. If you do have questions, feel free to quickly fill them in now, or you can follow up with me after the session by emailing me on my email shown on the screen or connecting with me on LinkedIn. Otherwise, I would just want to say thank you for your time today. I really appreciate your attendance. Hopefully we will have I don't believe that the registration page is up for the new webinars as of yet, but I'm hoping that they will be available in the next sort of 24 to 48 hours. So keep an eye out on that registration page for some of the new webinars that we mentioned a little earlier in the session. Otherwise, thank you for your attendance today. I really appreciate your time. I hope you've seen some value in this session, and I look forward to seeing you at one of our future webinars. Bye for now.